In this video, I want to use the bicycle to study two types of forces, frictional force and the normal reaction. Now, over here, we have a bicycle which is moving in a straight road, in a straight path. What are the forces which the bicycle exerts on the road? Let's look at the points of contact between the bicycle and the road. The bicycle makes contact with the road at this point and at this point. The rear tire is the driving tire because we know this chain is connected to the driving tire. So we are going to concern ourselves with the forces which are exerted on the driving tire or the forces which the driving tire exerts on the road. Now, how do these forces come about? We obviously know that it comes from the cyclist. The cyclist applies forces on the pedals. Then that force is transmitted to the rear sprocket here using the tension in the chain. And that force is transmitted to the tire so that the tire starts turning like that. Now the tire makes contact with the road surface. The first type of force that the tire exerts on the road surface is its own weight. You see, this force comes from the weight of the bicycle. We know that the weight of the bicycle means this. The earth exerts a force downwards on the bicycle. So the road surface interprets that to mean that the bicycle is exerting a force on it. It's just the same as this object here that I have on my hand. That object has got a type of force which is exerting on my hand. My hand interprets that this object is applying a force on my hand. But actually the type of force which this object exerts on my hand, it does not come from the object itself. It comes from the earth because the earth is trying to pull this object vertically downwards and my hand is preventing it from moving in that direction. So as far as my hand is concerned, this object exerts a force on my hand. That is what is happening to this bicycle here. The bicycle exerts a force on the road surface equal to its own weight. So we are going to consider that section of the total weight of the bicycle which is exerted at this particular point. Now the other force that the bicycle exerts on the road surface is due to the fact that at this particular point the tire tends to push the road backwards. And this is the force that is exerted by the tire backwards on the road surface. It comes because there is friction between the surface of the road and that of the tire. So when you add those two forces, remember we are looking at the forces which the bicycle exerts on the road. One of them is the weight of the bicycle. The other one is this force which we can call the driving force because it comes from the tire itself. So if we add these two forces, we are going to get one force, this force here, which the bicycle exerts on the road. So the one force which the bicycle exerts on the road is this one here. This force has two components, the driving force and the weight of the bicycle. Remember, the driving force is generated by the bicycle. The weight is a property of the bicycle. So the two are two forces exerted on the road by the bicycle. Now let's look at the forces which are exerted on the bicycle by the road surface. Because according to Newton's third law, for every force there must be an equal force but acting in the opposite direction. So the first force that the road surface exerts on the bicycle is this one here. It is usually referred to as the normal reaction. Normal reaction. But the real term used is the normal component of the contact force. normal component of the contact force. So remember, this force is exerted on the bicycle by the road surface. The other force which is exerted on the bicycle by the road surface is a reaction to this driving force here, and it points in this direction. So this is the true driving force, and it is exactly equal to the frictional force which the road surface exerts on the surface of the tire. In fact, it is referred to as the frictional component of the contact force. Frictional component of the contact force. So the actual force which this road exerts on the tire is actually this one. This is the force which the road exerts on the tire. And it has got two components. It has got the normal component and it's got the frictional component. Those are the real terms, the actual terms which are used to describe these components here. The frictional component of the contact force and the normal component of the contact force. And this force is exactly equal in magnitude to this force here, but points in the opposite direction. Again, obeying Newton's third law. I've used this simple situation here because it is familiar to everyone. At least if you've used a bicycle before, these types of forces are this type of situation is familiar to you. I'm just explaining the types of forces which exist and how they are split. The same forces exist if this one was a motorbike or if it was a car. The only difference between this situation and the one for the motorbike is that the driving force in this case comes from the cyclist, while for the motor car, the driving force comes from the engine. So that is the only difference. Otherwise, when it comes to the contact forces, at this point, they are exactly the same, because it is important to understand how is it that when a wheel rotates, the vehicle moves forward. You've got to understand that the wheel is rigidly fixed to the bodywork of the car. And therefore, any force exerted on the wheel is the same force that is exerted on the car, and that is the force which makes the car to move forward. You've got to understand that. So through this simple simulation here, I hope I've been able to shed light on the types of forces which act when a wheel turns or when a wheel rotates, especially if it is the driving wheel.